Second Science. I'm Karen Hopkin. Some things are so adorable, we say they're cute as a bug's ear. Of course, bugs don't have ears. But a new study shows that orb-weaving spiders can use their webs to detect sounds. The findings are unfurled in the Proceedings of the National Academy of Sciences.
Any animal that makes sounds is likely to have an ear.
Ron Hoy studies neurobiology and behavior at Cornell University in Ithaca.
Ranging all the way from tiny crickets and flies that are even smaller than crickets, all the way through to humans, of course.
It's also pretty interesting that a great many animals don't have eardrums, but they still hear.
That's Ron Miles.
The two Rons here.
Ron Miles, who's been collaborating with Ron Hoy for 30 years, is an engineer at Binghamton University.
An hour's drive away from Cornell.
Critters lacking eardrums receive audio input via very fine hairs.
If you look at many insects and spiders, they're covered with hairs.
Because these wispy little filaments can float freely in the breeze, they're great at sensing the air currents that comprise sound waves.
We were kind of wondering, how would you make something that could sense sound the way some of these small animals do?
A possibility appeared during an afternoon stroll.
So my graduate student, Jen Zhou, he was walking in our campus nature preserve one day, and he noticed that when the wind blew, if you look at a spider web, it moves with the wind. And he thought maybe a fine spider web or a spider silk could act as a sound sensor.
To find out, the researchers coaxed a spider into giving them a bit of silk.
And we played sound at a little strand of spider silk and found that when the silk is very thin, it moves with the air in a sound field amazingly well over a wide range of frequencies from 1 hertz to 50 kilohertz. So we knew then that spider silk was sort of an ideal sound sensor.
Well, that was eye-opening for the researchers. But is it ear tickling for the spiders?
So we set out to try to figure out if spiders were actually able to hear sound using their web. And this was a hard question to answer.
For one thing, they had to find a way to get a whole web into the special soundproof chamber in the basement of the lab building.
Spider webs are very delicate. You can't go out in the woods and find a spider web and grab it and take it home.
Especially those made by the industrious orb weavers, spiders like the title character in Charlotte's Web.
We're talking about quite a spectacular web. It's this wheel-shaped web that around upstate New York, if you walk through any field, you're either going to walk through one or you're going to see it and avoid it because they're big. They can get to as big as a yard or a meter across.
So Jen Zhou and fellow student Junping Lai came up with a way to get custom-made webs to go.
What they did was make a little wooden frame, kind of about the size of a decent-sized picture frame, and they placed this frame on the windows of our building.
The lights in the building attracted bugs, and the bugs attracted spiders.
So the spiders built their webs on the frames. Then, in the morning, my students would go and collect the frames and basically hijack the spiders and take them over and put the frame in the chamber intact.
Now, how can you tell whether a web functions as an arachnid hearing aid? Well, one way is to keep an eye on the spider's brain.
My lab, the neurophysiologist, made some recordings from the nervous system, sensory system, that showed that indeed you get an acoustic response in the nerves to sound coming from a speaker a little more than a meter away.
But even more revealing was how the spiders acted.
To very loud sounds, you could get a strong response. The spider would either flatten out or it might actually crouch, but it's really hunkering down. That is indicative to a biologist of an alarm response.
And when serenaded with sounds that are maybe 10 decibels or 100 times softer,
without changing its body posture or making any other movements, it might simply raise its front 2 legs off of the web.
That leg lift, says Hoy,
is the spider's way of maybe putting out 2 more sensors out there to see what's coming. We don't know that yet, but that response to a very soft stimulus might be simply the spider's reaction to, I know something's out there, I've heard it, but I need more information. So that's essentially the demonstration that was needed to show the spiders can hear sound.
This filamentous approach to acoustics could someday change the way we make microphones and put a whole new spin on webcasting.
这边主要是在说，蜘蛛他们可以用他们词去听声音，然后他们就有做了一些实验，像是用 bug， 就是用虫虫跟 spider 他们之间的实验，然后还有用他们的脑袋去分析说，他们为什么会有感觉到会有声音之类的东西。
他讲说那个他们刚开始观察是说他们用网子当做他的耳朵，就是用网子可以听到声音，然后后来还有就是也是一样做很多实验，然后有一个讲到说可能是风啊，就是风的那个关系，所以他也听得到。对，所以还有说反正就是很多假设，对，差不多。